Welcome to our new class. So, we are going to learn the first chapter in physics in class 11. So, the chapter is units and measurements. And you all know that in your textbook, the whole content, it is divided into several units. So, some of the units, it has like 2 to 3 chapters in it, and several other units, they have only like one chapter. So, here you have the first unit. It has only one chapter in it. So that's the first chapter that we are going to learn today. That is units and measurements. So before going into the chapter, I want to tell you that this is one of the most important chapter you have to study. Not because it has like uh, more marks from this chapter. It has from this chapter you'll get only like around 2 to 4 marks for your examination. But that's not the thing. Uh, most students, when they know that they have only like 2 to 3 marks from this chapter, they'll just neglect the chapter and they won't study it for the examinations. Please just don't do that, because first thing is that is the easiest 2 to 4 marks you can score in your examination. So every mark counts. So that's the first thing you need to be aware of. And the second thing is, this is one of the basic uh, ideas that you should know while you are studying all the other chapters, or in your class 12, or in your further studies, not only in physics. Everywhere you are going to do some calculations and measurements, practicals, everything. For everything, you need to have the basics of units and measurements. So that's the most important thing that you should keep in your mind. Don't ignore this chapter. Please learn it because it's very important, especially while you're studying science, which has all these experiments and measurements, and it's all about measurements. So keep that in mind before you are learning this chapter, okay? So the main important topics in this chapter is the first one, introduction to units and measurements. So first we'll learn about the basic ideas of measurements, different measurement systems, and the units associated with it. And then the next topic we'll learn in this chapter is precision and calculation rules. In precision, you will be learning significant figures. You don't have to be worried about all these terms. It's very easy topic, very easy to learn. So I'll teach you all this. And some calculations using the significant figures. And then you'll study the dimensional analysis and some practical applications where, again, you'll be dealing with some numerical problems based on the dimension. So these are the 3 important topics that you're going to learn in this chapter, and it covers all of this chapter. Earlier, you also had to learn error calculation and all. That's actually been taken away from your syllabus for your examination. But if you're preparing for the NEET exams, you will have to learn error calculation as well. But for your examination point of view, for your uh, class 11 examination, you don't have to study error calculation. So that's a plus point for you. So before going to the chapter, I want to tell a quote by Max Planck, the famous physicist. So he's telling, an experiment is a question which science poses to nature, and a measurement is the recording of nature's answer. So why are we doing all these experiments and developing all these new technologies or whatever we are using in your daily life? Because we are doing these experiments to get some answers, right? To get some answers, you are doing these experiments, and all these questions are towards the nature, because nature is the basic of everything. So we are asking these questions to the nature by doing experiments. And what do we get from that? We get measurements, which is the nature's answer. So see, measurement is that important because for any of our queries to the nature, measurement is the answer. Why? Because while we are doing with science, science is not about an opinion and it's not about assumptions, right? We won't do an experiment and we won't be like, oh, let's assume this is the answer. No, we won't do that. We take proper measurements. So science is all about facts based on systematic experiments and accurate measurements. Precise or accurate measurement. Science is all about facts. So that's why measurement is very, 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 very important while you are learning science or physics, even in chemistry, sometimes in biology as well, you will have to deal with these measurements. So that's why measurement and this chapter is very important. So while we are talking about measurements, think about it. In your daily life, you are actually doing so many measurements every day. Is it right? So let's go to some of the examples of the measurements that you do in your daily life. So the first thing you can see here, there's a clock here. So this will be the first measurement that we'll be doing when you wake up, the first thing in a day, right? You will wake up and check your phone. What's the time? Am I late? Or am I early? Have I got some more time to sleep? Right? And again, when you are in class all through your day, you'll be checking your watch. How long is it for the period to, end? How long does this class long last? Right? So time is one of the basic measurement that we do every day, right? So here you can see that the time is around 9:26. We don't know if it's AM or PM, but again, we know that it's 9 hours and 26 minutes, right? Yes. So you got a measurement here, right? In hours and in minutes, right? So this is a basic measurement that we all do every day. Again, you have another calculation, measurement here, the length. See, length is another calculation, right? So you have here they have measured the length of a pencil. It is given as 37 millimeter, right? 37 millimeter. Sometimes if you're asked about your height, you might say it is 168 centimeter. So see, again, another measurement of length but in centimeters. Suppose you are asked how long is how much is the distance from your home to your school? You might say around 3 kilometers. Again, it's a measurement of length, see, but in kilometers. So these are all the measurements. Again, this length measurement we do every day, especially when you're doing mathematical, geometry and all. You'll be using this a lot, right? So that's length. Next one, mass. Again, in this nowadays people are very conscious about their health. So they usually check their weight regularly. So here, this person, he's got a weight of 85.4 kilograms. See, the mass measured in kilogram. Again, this is, see, here you have a smaller scale of mass. So here you can see they are weighing groceries. They are weighing tomatoes here. So the tomato, the weight here, you can see that mass is again 89 grams. So here the measurement is in grams. So see, mass measured in kilograms, here mass measured in grams. this is another example. You or your parents will be going to purchase groceries and things like that every day. So there you all use this, what, weighing scales, right? Next, see this. What is this? It's a speedometer, right? Speedometer. So again, this, if even if you are going in bus or car or bike or any vehicles, all these vehicles have this speedometer to measure the speed of the vehicle, right? So here you can see that there are two measurements, one in speed measured in miles per hour and the other one in kilometers per hour. So we can measure either in miles per hour or in kilometers per hour. So you can see that here, this is miles per hour, that is around 69 miles per hour. Or you can see that here, see, in kilometers per hour, it is around 110 kilometers per hour. See, same measurement in miles per hour and kilometers per hour. See, this is again daily life. You use this, right? Okay, the next one, you all have electricity in your home. So, electricity measurement. So, a person from the electricity board, they'll come and uh, take the reading and they'll tell you have used this much amount of current and they'll give you a bill uh, to for you to pay. See, this is again another measurement that is used in your daily life. It is actually measured in kilowatt hour. So the power consumption is actually measured here, okay, in kilowatt hour. Okay, so these are some of the examples of measurements that you use in your daily life. There are several other measurements that you use in your daily life, and these are the basic measurements that you use in every day. Okay, so let's go to the learn more about the units and measurements. Okay, so physical quantity, this is one of the important term that you learn in this chapter, and you can see that in your textbook this term is used several times in the first chapter, physical quantity, and not only in the first chapter, in other chapters also you can see that the term physical quantity. So you need to know the meaning of the term physical quantity. So what is a physical quantity? So the term physical quantity, it is defined as any quantity that can be measured. Any quantity that can be measured is called a physical quantity. So if we can measure a quantity, it is called a physical quantity. How it can be measured directly or indirectly. Can be measured directly, either directly or indirectly. Anyway, if that can be measured, it is called a physical quantity. So that is the basic idea that you need to learn. First thing in this chapter, that is physical quantity, any quantity that can be measured either directly or indirectly. So you can actually think about so many examples that can be measured. What is it? We have already talked about length. Length, it is a quantity that can be measured. So it's called a physical quantity. Again, mass, temperature, force, electric current. These are all examples of physical quantities, but there are numerous other physical quantities as well. But one thing is, you shouldn't be confused with the term physical quantity. For example, I'll give you an idea about it. Suppose, usually when you have fever, you will say, oh, you've got fever, you got a high fever, right? You'll say like you have fever this much amount, or you got a high fever. So is fever a physical quantity? No, fever is not a physical quantity. We are not measuring fever there. We are measuring the body temperature there. So their temperature is the physical quantity, right? Not fever. So you shouldn't get confused with all those terms. And see, suppose you're very happy, but can you measure the happiness? No. So it's not measurable, so it's not a physical quantity. And if you're sad, you can't measure the sadness. See? So only the things that can be scientifically measured is called a physical quantity. Okay? I hope you understand the basic idea of physical quantities. Now comes the units. Why are units very important? Because in earlier slides, we have seen that, see, again, length measured in centimeter, kilometer, millimeter, again, mass measured in kilogram, grams. See, the same physical quantity measured in different units, right? But why is this unit very important? If for a physical quantity to be significant, is significant only if it has a unit along with it. For example, you are asked to buy 1 kilogram of apple from a shop. Your mom asked you to buy 1 kilogram of apple from a shop. So you went to the shop and asked the person there, I want apple. He'll ask, how much? One. So he might give you one apple there. See, you just said one. So you might be given only one apple, not 1 kilogram of apple. So only if you say 1 kilogram, then you will get 1 kilogram of apple because that value is significant only when this unit is associated along with it. So that's why unit is very, very, very important. I'll give you another example. Suppose you are asked, how much is the distance from your home to your house? So you are telling 3. So what is this 3? It can be 3 kilometers. It can be 3 meters. It can be 3 miles. It can be 3 feet, right? It can be any of this. But for the answer to be precise or significant, what do you have to tell? It's 3 kilometer because that's the right answer. It's not 3 meter, it's not 3 miles, it's not 3 feet, right? So that's why unit is very important. If you are, suppose you are doing a numerical problem in your examination and you find out the answer, you get the proper answer, you get the proper numerical value, but you forget to write the unit along with it. So does that answer have any significance at all? You might have done all the calculations really well, but the teacher can actually give you 0 marks for that because you haven't written the unit. So that term actually don't have any significance. Your teachers, they won't do it, but I'm telling you to get the idea of the importance of units. Okay. So now you might have got a got an idea of how important is it to write a unit. So just remember from now onwards, if you do any calculations, always write the unit along with it. Okay. Now, so you studied physical quantity and you know that for a physical quantity, you have a numerical value as well as a unit associated with it. So the physical quantity it can be represented as, if it is represented as Q, you can write it as NU, where N is the numerical value and U is the unit. So this is not N in multiplied by U. This is the representation. We have a numerical value and unit associated with it. Is it clear? All right. Let's go to the next topic then. So I have told you length measured in different units, mass measured in different units, time measured in different units, right? So the thing is, in different countries, they use different units to represent different measurements. Okay, for example, here in India, we measure the mass, usually measure the mass in kilograms, right? But the same thing in UK or European countries, they use measure the mass in pounds. See? And we usually use measurement of length in kilometers or meters, but there they use feet. So different measurement systems are used in different countries. So such measurement systems are given here. First one is the CGS system. CGS system means length in centimeter. What? Length in centimeter, and mass in grams, and time in seconds. All right, length in centimeter, mass in grams, and time in seconds. Again, you have the MK system. You can actually answer this. What is MK system? M represents meter. Yes, length in meter. K, what is K? Yes, mass in kilogram. And then what is S? S again, time in seconds. Then you have the FPS system, which is what I told you, like the one which they use in UK and other European countries, which is length in feet or foot. Then mass in pounds. And again, time in all the system, you measure it in seconds, represent it in seconds. So these are the different measurement systems that you use in all over the world, in different countries, different measurement systems they use. But if you are doing a scientific experiment, this is not actually the right way. Right? Suppose I am doing an experiment here and I am writing an answer in terms of meter, kilograms, and seconds. But the same experiment, some other person is doing it in some other country, and he is representing it in feet, pounds, and seconds. Since it is a scientific experiment, it is not good to do it in different measurement systems. So, for that, the scientific community, they developed an international system of units, system internationally, in which the system, a system which is accepted all over the world, internationally accepted, particularly for scientific experiments and in industrial calculations. So that in anywhere in the world you are doing an experiment, it is what? Represented in the same system of units. So you will get a unity, or you won't get confused with the results and things like that. So that's why you are using international system of units, that is the SI units. Very, very, very important, because you need to know all these what measurements or the physical quantities, how they are represented in SI unit, SI system, and what are the units. Okay, so that's why, that's the importance of SI unit. Okay, so let's go to the next topic. So since we have different measurement systems, not in the scientific community, but in general, you have different measurement systems. So you need to be very, you'll have to know about the conversion of these measurement systems. That is 1 centimeter is 10 millimeters, 1 meter is 10 centimeters. So this basic conversions you'll have to memorize, because you'll have to use this in your numerical problems. So these conversions are very important. These are the basic conversions, and you have several other conversions as well. So just be careful. These basic conversions, you need to be very, you need to keep this in mind. So these are the different conversions. 1 centimeter is 10 millimeters. 1 meter is 100 centimeter. 100 centimeter, we can also write this as 10 square. That much centimeters. And 1 meter is 1000 millimeters. How we represent 10 cube? 10 cube. 10 cube millimeter. And 1 kilometer is again 1000 meters. So 10 cube meter. Right? So similarly here, 1 gram is 1000 milligram. 1 kilogram is 1000 gram. See, 1 liter is 1000 milliliter, and 1 kiloliter is again 1000 liters. All right. Yes. So these are the conversions. And suppose you are measuring a length 5 kilometers. How do we represent it in meters? So 1 kilometer is 1000 meters. So 5 kilometers will be 5000 meters, right? Again, this is again in centimeters. How many centimeters? So 1 meter, it is 100 centimeter. So this will be, add 2 more zeros, that many centimeters. See? Again, if you have 5 kilogram of some substance, so how represent it in grams? That will be 5000 grams, right? Again, in milligrams, how much it will be? 5000 grams. 1 gram is 1000 milligram. So 5000 gram is 5000 into 1000, right? That many milligram. So this, we can write this as 5 into 10 power 3 meter. This we can write it as 5 into 10 power 5 centimeter. Here you can write this 5 into 10 power 3 gram, or 5 into 10 power 6 milligram. Okay. So what do you understand from this? Here, kilometer and kilogram, they are the highest units, right? And when you go down to lower units, you can see that the numerical value, it is getting bigger, right? Again here, 5 kilogram, when you convert it into grams, that the lesser unit, the numerical value becomes higher. So, higher the unit, lower is the numerical value. Higher the unit, lower is the numerical value, or vice versa. If lower is the unit, higher is the numerical value. Did you get the idea? Higher the unit, lower the numerical value. So you can write this as, so they are like inversely proportional. If one is higher, one is lower, right? So it is inversely proportional. So you can write this as N inversely proportional to unit. Okay. So that's a very important idea you need to be aware of. All right. So I hope you understand what you have learned till now. So we'll learn the rest of the chapter in the next sections. So till then,